Okay, we try that problem, 6, 7. First one, Newton. 6, 7. Y of t is equal to negative 4.9 t squared plus 20t. This. Take the derivative. So we're going to go negative 9.8 t plus 20, agreed?
Yes.
And then I'm going to plug in 2 if I want to find it at 2. And that's going to give me negative 19.6 plus 20, so it would be what? 0.4 meters per second, or whatever the units would be. I don't know if it's meters per second of the problem. Good?
Yes.
What would be the velocity equation for any time with respect to t?
Negative 9.
So this is the answer to the second one.
Yes.
Right? All right. And now for something completely different. I'd like you to try, let's say I throw a rock up in the air, since velocity can be modeled as negative 9.8 t plus 20. What would be its displacement 2 seconds later? Now Newton asked, don't we already know this answer? Feel free to graph, find the curve, find the limit of smaller pieces. Or what should we do?
Just plug it back into the original.
Take this, v of t, and go backwards. Going backwards is technically the integral. So we write the integral sign with a little dt hanging off the back of it. And integral dt. That dt tells us where we're taking the integral. It's actually important you know which letter you're taking the integral of. Because down the road, there's going to be 3 or 4 letters in the problem. And it's a problem if you don't keep track of which one you're actually integrating. Does that make sense? Okay. So I'm going to get a of t, and that's going to be equal to, well, y of t, not area. I'm trying not acceleration, but y of t. So I got y of t, and so therefore I'm going to raise the power by 1, right? Divide by the power I get. Raise its power by 1. Divide by the power I get. And look what I get. Negative 4.9 t squared plus 20t. And that's what we started with. And so I can do that consistently. I can find the displacement that. By the way, those of you in physics class say, I've seen this before. Where do these formulas come from? I drew this strange shape, but I drew x's and... It's calculus, folks. We're doing calculus. We've been doing calculus all year long in physics. They just don't know it. You don't have to tell them, too, because it freaks them out. All right, moving forward. Does that make sense?
That's what I noticed, like the position, time graph, and like the slope, the derivative.
It's just the derivative. We can't call it that because we don't know what a derivative is, but we are doing calculus. Calculus was invented to solve physics problems. It was invented by a guy named Newton, who was doing physics at the time. That's why it was invented. Most of the applications for calculus that we come up with in the very beginning are all physics problems. That's why there's so much physics in this class. That's why the fact you don't need knowing physics. All right. All right, move forward. Flip this over. So antiderivative. We're going to use the antiderivative. We're going to go backwards through the problem, right? So every question, we're going to do Jeopardy, right? We're going to say, if this is the answer, what was the question? Okay? So if the answer is, if dy dx equals negative 2x cubed plus 6x, and I want to find out what y is, what do? Ms. Leoncio, what am I going to do?
You're going to raise the power by 1.
Raise the power by 1.
Divide by what you get.
Divide by what I get.
Raise the power by 1.
Raise the power by 1.
Divide by what you get.
Divide by what you get. And that's my y equation, right? So that's how you integrate. Got it? Just that simple, sort of. Okay. Blow through exercises 5 through 13. Blow through exercises 5 through 13. I'll start writing answers up here. Have you got this? I'm going too fast, Hummer. Just slow down?
Yeah.
I apologize. I'm on the back. That's part of the problem.
What?
You in the back? You're in the back.
No.
Okay, I'm on the back. This is the question on the back. This is the problem on the back. So if this is the problem, here's the answer. You don't have to race the front. Get the back done. Let's go. You have it written down twice. That's all right. I'll live with that. So if this is the equation, that's the derivative. What's the original equation? If this is the rate, how many cans are on the floor? Right? That's what we're doing. So on 5, they give me the rate is 3t squared. Raise its power by 1. Divide by the power I get. Y of t equals t cubed. Six is a little tricky.
Yeah.
Because it's pi. Is pi a number or a variable? It's a number, so it's like 3. So I'm going to raise the power by putting a t on there at all to begin with. Divide by the power I get. Since that's t to the first, I'm getting a 1 down here, so I'm done. That make sense? All right, I'm going to slow down a little bit, Hummer. So I'm going to raise its power by 1, x to the 5 halves, divided by power I get, 2/5. Now that's a fraction divided by fraction, so I'm going to flip and multiply. I get 5 halves x to the 5 halves. If you do this enough times, eventually you stop putting it down here and just flip it and put it in front. And that's fine. However, are you erasing things? What happened? Okay. And then 8, here we try 8. Now this one stumbles people. Why does it stumble people?
Oh, because it's negative.
It's negative, so by raising it by 1 makes it -2, right? So this becomes 2x to the -2 divided by -2.
Okay.
Which gives me -x to the -2.
Fair.
Yes, sir.
On number 7.
Yes.
When you divide by 5.
I did. Oh, I didn't flip. I did that wrong. Woo!
Oh,
Yeah, I was.
wait, that's
terrible.
why I erased.
Terrible. Well, then catch me at it. Say, hey,
Well,
that's
I
not
thought
right.
I was just wrong.
Ah! Ah! Here we try number 9. What do you mean by rewrite? Right is a power function, right? So you can do the integral easily. Get rid of those stupid bars. Get rid of things in the bottom. Nine. So I got 9. I get the integral of x to the cube root of x. As always, roots are a horrible thing. I don't know why they exist. Raise its power by 1, divide by the power I get, and there's my answer.
Yeah, I got one.
Right? Then the next one on 11, they give me the integral of 1 over x squared root of x dx. That's a little confusing. That's the next, so I can rewrite this as the integral of x times x to the 1/2 power. Does that make sense? Now, since the base is the same, I'm going to add the exponents. So I can rewrite that as 1 over x to the 3 halves, or 1 1/2 dx. And then I go one step further. It's equal to the integral of x to the -3 halves, right, because it's on the bottom. Now I'm ready to raise this power by 1. Divide by the power I get. So when I flip, I get -2x to the -1/2. Roger that. All right, go to that last one, and then we'll get some practice.